I am Dr. Matthew Edwards, a faculty member in physics at Alabama A&M University in Huntsville. And it is my pleasure to introduce the first speaker in this session. He's a colleague, Dr. Thomas J Marlowe is a professor of mathematics and computer science at Seton University, where he was the coordinator of the computer science program until beginning phase retirement this summer. His research spans many areas with publications in software engineering, collaborations including risk analysis, intellectual property issues, developmental structure and processes, and in information science, language support for real-time system, program optimization and analysis, and computer science pedagogy, including problem solving and critical thinking, as well as topics in mathematics, information science, and interdisciplinary studies. He holds the BS and MS degree in mathematics from Seton University and an MS in computer science and a PhD in computer science and a PhD in mathematics, all from Rutgers University. He has been a regular at this conference since 2008. Please welcome Dr. Thomas J Marlowe.
I would like to thank my colleague for that gracious introduction and say that I'm here because Najib asks me to give a talk on whatever I happen to be thinking about every given year. It's always a little different. And this year what I'd like to talk about, and I apologize to a little, at least, to people who were here on Saturday to hear me talk about it already, has informatics changed the intellectual landscape? And a secondary topic, are the mathematical sciences becoming a distinct, incomprehensible culture and language? So some key things to think about as I go through this. What are the implications of the mathematical sciences? And we can throw statistics and data science in there for research, for communication, for collaboration, for interdisciplinary projects. Are the mathematical sciences becoming their own culture, becoming unintelligible to other disciplines, even as they become more important to them? And what are the implications for the education of academics and other professionals, including in the mathematical sciences? And what are the implications for interdisciplinary ventures, projects, and research programs? And I started thinking about this maybe 20 years ago, which shows how long it takes some things to come to the fruition for me, when I was on a college academic policy committee that approves programs and courses with colleagues from other disciplines, and we'd get a course in the humanities, and I'd look at it and say, okay, I can see what you're trying to do and why you're trying to do it, and a little bit of how you're trying to do it. And we got a course in the social sciences, and I can see what you're trying to do and why you're trying to do it, and a little bit of how you're trying to do it. And of course, in the sciences, I could do the same. And when I was on a university committee later, courses in business and in nursing. And then we would get courses in mathematics and in the non-applied or systems areas of computer science. And I would have a battle trying to even explain to my colleagues why this was interesting, why it was important, where it fit in, what it was doing, and how it would go about it except for the coding. So you get to think, maybe that's hard. Maybe things are really different. And then you go and you try to explain to your family exactly what your research is. And if you're in the sciences, you can say, well, I'm studying something that will have some effect on pollution. I'm studying something that will result in a cure, give better products. If you're in psychology or sociology, how people interact, how people think about things, how people perceive things, and so on. And if I'm in mathematics, pure mathematics, I say, we're working on things that are intellectually interesting in the hope that in 50 years somebody will find a way to use it, which, by the way, has happened many times, but in many cases it has waited 50 years. Euler's famous Königsberg Bridge problem, which was a mental recreation, is now one of the most important areas of mathematics, graph theory, and has spawned several other areas. And that's more like 225 years. So, very interesting. Okay, so some low-hanging fruit. And given Florida, what could I do but oranges? The social environment, social media and internet environment, the Internet of Things, the cloud, all of these things we've been hearing about in, I don't know how many you went to, but I've at least a dozen talks for me today, have changed how we're communicating, how we search for information. Are there actual changes to how we structure our research, how we think about things? Do open access research sites change the way that we communicate, change the way we form communities? Are the changes largely superficial? Are they mostly just an accelerant, or are they substantial? Are there negative effects? One thing with all these open access journals is, given some of the review standards, it's now hard sometimes to know how reliable the research is, and that's certainly true for internet search. Okay. And collaboration tools, as well as all of the social media, have made collaboration much easier, have made collaboration, remote collaboration, much more fine-grained. I can and literally have gone in and in a shared meeting of some sort or shared edit, been able to do fine-grained editing of grant proposals and articles line by line with somebody in another continent. Has this made collaboration more common, easier? Has it, through availability, made us stick more to our own community because now we can communicate to people who are very close to us? Or has it encouraged broader collaboration? I think it is true that joint authorship is becoming more common and easier. Is it more standard now that everybody looks at all of the article, or is it the old style where I write section 1 and Najib writes section 2 and Andres writes section 3 and Matthew is doing section 4 and checking the bibliography? Thank you, Matthew. Okay. And, okay. Second item, I think, how about data science and the digital humanities? Data science has certainly changed the way research is done and the way it's presented. It's altered what research is considered interesting. Is that positive, or is it mixed? Is the emphasis now on so much turning to, or will be turning to, the digital, that people who want to publish old-fashioned critical studies of a work of literature are going to find it harder or less prestigious? I don't think so. I hope not. But I think it's a legitimate concern. Does it discourage, now that we have all these wonderful quantitative and data mining-based tools and approaches, does it discourage the formation of new models in the humanities and social sciences? Certainly, data science allows more complex, or at least complicated, questions to be asked and sometimes answered. We can do data mining to find all sorts of associations. Is this a real benefit, or are we at least sometimes just chasing our own tail? Okay. Has the fact that this tends to, again, emphasize the quantitative, the commodifiable, the actionable, not in the legal sense usually, is that going to have a positive effect, a mixed effect? It's tended to shorten the research timeline, especially in the humanities, social sciences, and decision sciences. Are we doing enough thinking? Or are we just throwing tools at a problem and accepting the results and trying to publish quickly? Okay, will the development of the digital humanities strengthen or save the humanities? One of my colleagues in history thinks the humanities are about to disappear as an academic discipline. They're not getting the students. Their research is broader, but again, becoming less humanistic, more quantified. Will it require changes in the viewpoint or education of humanities faculty? And I think that's just going to happen. And how much influence will what the digital humanities does have on the social sciences, on professional fields, back on informatics, even on the sciences and mathematics? I suspect it will have some influence on statistics at least. Different parts of statistics are becoming interesting. And my first foray for the talk, to what extent are the people who want to use data science in control? To what extent do they understand what's going on? To what extent are they going to more or less be at the mercy of the algorithms, the data mining, the searching, the association, statistical, neural networks, algorithms that are provided to them? How much control are they losing of their own research or product development? In many cases, in the commercial world, that's going to be positive, but are we sometimes at least reducing or eliminating intuition when it may be valuable? Something that is ahead of the curve rather than following. Every single thing I'm saying is debatable, right? Since this is about the only place I can go and ask questions and be applauded, I'm just going to do it. Okay, so do we have three cultures? And we can argue for more, but I think this is important. In the 1950s, C.P. Snow wrote a number of works, lectured a number of times, gave presentations, became famous, or became also famous, for his perception of the two cultures. Granted, this was in England in the high universities, Oxford and Cambridge. But his perception was that there was a growing gap between academics and researchers in the sciences and those in the humanities. The scientists tended to look down at the humanists as not doing real research, and the humanities faculty neither wanted to grasp nor often were able to grasp what was going on in the sciences. He said, every scientist can tell you who Shakespeare was, know some of what Shakespeare wrote, and can do at least superficial analysis of a Shakespearean play. And it's rare to find an academic who understands what the law of gravity, in the humanities, who really wants to understand what the law of gravity does. I exaggerate, I hope. Okay. So scientists said, everything should become science. Everything should become quantitative. And the humanists said, who needs science? We're doing the real academics. We are in the liberal arts tradition, ignoring that 3 of the 7 liberal arts were arithmetic, geometry, and astronomy. Okay, so a real question is, was this just social? Was it just historical accident, or was it really due to a difference in terminology, idioms, concepts, patterns, both of practice and of thought, practices, approaches, and philosophy, even when the problems overlapped? The questions of interest were so radically different and the methods different. Was this inevitable? So this leads to, I think, the interesting question: have mathematics and computer science become a third culture? Is this real? Is it conceptual? Or is it primarily due to siloing and turf protection and lack of interest? Anybody who is in a university, and most people who work in even a medium-sized business, know all about siloing and turf protection and lack of interest? Or is it due to real allopatric speciation? So allopatric speciation is this time when a subpopulation goes away, is isolated by itself, talks to itself, breeds with itself, and later cannot really communicate to other cultures. So for the most part, humanists have neither wanted or needed to deal with the mathematical sciences, although in many cases they understand some of the very early work, or the interaction often of logic with their own disciplines, even, I know, among our philosophy department. We have maybe 10 full-time faculty and a number of adjuncts, large number of adjuncts, and maybe 3 of them are willing to teach a symbolic logic course. Social scientists and scientists have generally been satisfied to be consumers of mathematics, while I acknowledge that very good mathematics has sometimes come from psychology, political science, decision sciences, theoretical physics, science in general, and engineering. And philosophers and others have certainly contributed heavily to the theory of logic, especially early on, but even 19th and 20th century. So mathematics was left alone in its own set of silos, driven by a very different fitness function, have developed very much their own language, and this has been followed by theoretical statisticians, mathematical logicians, computer scientists, informaticians, AI researchers, data scientists, where the key notions are not generally modeling the real world, although that's something they're willing to do, but abstraction and precision. So taking graph theory away from the map of islands and the map of cities and the map of relationships and the map of a supply chain and whatever, and just look at the properties of the underlying graph. To what extent is this real? My own perception is it takes an effort nowadays to reach across the gulf from any side. Okay? And mathematicians often deal, as I've said, with issues of no immediate and sometimes no ever value, and they value it. And that's very hard for most others to understand. So, changing back to an informatics focus, does informatics support, inhibit, or not affect interdisciplinary ventures, projects, teams, research programs, research initiatives? Does it change the preparation that the non-informatics specialists should bring to the table? If so, how can we prepare them? Have existing interdisciplinary and cross-disciplinary projects helped to bridge the two-culture or three-culture gap? Can informaticians serve as translators between other disciplines, including their own? And my sense is this will require additional training and sensitivity and practice, but that requirements, specialists, and systems analysts will be most likely to be able to fulfill that function. Or perhaps it will serve as a dam. Okay, you give your idea, if anybody remembers the old-time IT departments, where you had to put things in exactly the right format, give them something, wait for a day, get it back, fix a few things, give it back to them, and then they would say, well, this isn't quite what you ought to be doing. You're not following process, or this isn't the right way to do what you're doing. Okay. Or perhaps will serve as a bottleneck or even a burial ground for ideas. As I was mentioning to Najib, there's a famous Goethe quote, "A mathematician is a kind of Frenchman. You say something to him, he translates it into his own language, and suddenly it's no longer the same." Okay, but we need repeated efforts to break through that dam, to break through that bottleneck. We have to keep talking to people about, they have to keep telling us what they want, and we have to keep telling them what we found, because otherwise they don't understand. Or maybe we'll become a secret priesthood, you know, with these robes and medals and ceremonies, and we have to get you to prepare your data in the proper format according to the date, time, and astrological configuration. And then we'll bless it and put it in for processing and give you our results. And as I said, invest in sacrificial goats, it's likely to become a good market. Another issue is, can business, can science, can the humanities, as far as digital humanities go, can the social sciences learn by exporting software engineering practices? Okay, especially requirements, agile in the sense that the computer community means it, which isn't necessarily the way the business community always means it. Where the business community seems to mean hire as few people as you can and pay them as little as you can, and you can always get more later, as opposed to the mythical man month, a long honored book of software engineering that says you can't just add extra people. Maintenance, evolution, long life of a project, and again, the more complex the project, the more likely it is to need these techniques. Okay. So again, same questions. As another view, which was expressed on Saturday, but I already had, perhaps mathematics and statistics produce enough tools. They feed computer science and software engineering, which produce tools, and they feed data science, which produce tools. Maybe those tools are enough. And I'd say, well, sometimes. Okay. For standard, well-understood, straightforward, replicating projects, for projects that combine old approaches in well-understood fashions, they work perfectly well. If you're going to specialize a project, if you have extra needs, complications, again, a need to port, to reproduce elsewhere, to continue working, you may need to ask the specialists to produce special tools. And you may need to talk to them to do it. Okay. So we see, for instance, that this has given rise from SQL to no SQL approaches, and from simple relational algebra to model practices to using mathematical and computer science structures. Okay, 5 minutes. Information, education, and informatics. Everything interdisciplinary now seems to require an informatics component, and may require, certainly, sometimes a statistical component, but the statistics often fits pretty well. Not always. The informatics often needs to be adapted. So we may require specialists in these areas, and we need collaborators who are comfortable with exploration, mapping, translation, integration, presentation of multiple views so we can move from viewpoints to viewpoint in a project. We can no longer rely on pure luck to get the translation right. Polymaths who happen to speak both mathematics and history, although we have more than our share here, or those fortunate to have had just the right education. In the informatics component of anybody's education, is it sufficient to concentrate just on discipline-specific or purpose-specific tools, or should we be exposing people to a more general view of what informatics and computing does? Possibly on the grounds that they may need to talk to people or that they may need to borrow tools or explain to the informatician what they need. Okay, and can we create the body of intermediaries? How can we prepare these intermediaries and change managers to work with multicultural, intercultural, transcultural, interdisciplinary, multidisciplinary, cross-disciplinary, transdisciplinary specialists? Isn't this something that we should actually be asking of the transdisciplinary specialists, by the way? This is now a means of communication and a means of interaction. Oh, come on, this should work. I don't have the same slide 4 times. Okay. Andres, if you're here, I'm stuck. Yes. El gran y el bueno Andrés. Okay. Okay, well, okay, we're working. Okay. So, all right, so what can be done to include a broad-based well, first, for the informatician, we also need to change the education of the informaticians to include a broad-based philosophical, historical, ethical mix, multidisciplinary and integrative perspective. And we need to make sure that this is common to all researchers to the extent possible, and try to minimize the difference of gaps in differences in culture and improve the quality and utility. Okay, so finally, how can we, I'm going to cut, you can read this slide quickly. If you can't, it'll be available on the feed. Okay, and how do these systemic disciplines fit in? And how can they be integrated with other perspectives? And how can we incorporate the perspectives and the knowledge and the viewpoints of different populations, different demographic, academic, and experiential backgrounds and focus, both at the academic table and out in the field on the project? How can we make sure that we get the viewpoint of people? One tends to think of this as a women's perspective, but it isn't just the caring, the societal concern, the larger view. And how can we get the focused disciplinary view and get them both at the same time? Okay, and how can we ensure that these are not only taken care of in the details of the program, but its framework and its vision? Okay, finally, and again, I'm not going to go through this. We have I've been developing with Susu Nusala, who's now at Shanghai, I believe, and Jeremy Horn and Najib and a few other people, a possible proposal for an interdisciplinary graduate degree, possibly as a second graduate degree. And we could possibly just extract pieces out of it as to complement anyone else's degree to try to prepare the necessary interdisciplinary specialists. And looking back at my initial slide, which I stole from my colleague, Father Joseph Laracy, I don't know where he stole it from, but that's okay. I was noticing as I looked that the silos actually are exactly precisely isolated. The upper right are humanities, the lower right are the sciences, the upper left is exactly the mathematical sciences, and then we have the integrators. And this is what we need. We need to bring them together because the tools of each discipline are going to be so important for the others. And I would like to thank a whole raft of people, some of whom are here or have been affiliated with this conference, and others of whom are at Seton Hall or have been my research colleagues. And I thank you.